Let's look at univariate outliers. It is very important for us to detect what we refer to as univariate outliers, because those outliers, as we call them, are observations which can have a huge impact on our results. And very often those outliers occur because of some errors in data collection, in data coding, or data input. And those errors, if carried forward, might lead to erroneous results, and we don't want that, definitely. So it's very important to know how to detect outliers. So in this lesson, I'll teach you how to detect outliers and then how to take remedial action when having outliers. So let's go through this. So first, let's understand the concept of outliers, which is, as we said, about any observation which are uniquely different from the majority observations. Here you can easily see, if I ask you which of those fish here are like, odd, kind of unique, different from the others, and you can easily spot out the red one here. It's different because of its color. It's different because of the direction in which it is swimming. So you can easily spot him, and that would be an outlier. Now it could be that we have it here by mistake, in which case we need to remove it, or it could be that it is a genuine case, in which case we need to take a decision whether we need to consider it or not. Here we have a case of apples, and you can easily see that the outlier here is this red apple in what could be a box of green apples here. So a red apple is here. So is it by mistake or is it on purpose? But it is important to know them first of all, and we decide what to do with them. We need to be able to identify those. So in those two cases, you can see it's very easy. But when we have a large data set with a large matrix of numbers, might not be so easy to detect outliers. Now, there are various types of outliers. The first type of outlier that we really want to spot and take immediate action is those outliers which occur because of some errors in data input, in data coding, data collection. We then have outliers which are genuine. Then we can or might not be able to explain those. In those cases, then we need to take a decision. Okay, but again, as I'm saying, first it's about being able to detect them, and then we can decide what to do with them. So outliers might be having a huge influence, okay, on our analysis, on our results once we perform any statistical analysis. So we want to be able to deal with those, to detect them and deal with those. In some cases, outliers might be beneficial, you see. It's not that outliers are necessarily bad. It could be that outliers are representative of a population, in which case we want to know about those. Okay. Yeah, so now let's see how to detect them. It's very important to detect them because if we have outliers, very often we can't use some specific analysis. A simple example will be like using the mean average score. So if we have outliers in a data set, it's not a good idea to use a mean, because you have skewed data and the mean won't be a good measure of central tendency. Instead, it's better to use a median. If you have outliers, it's not a good idea to use then parametric test to test for hypotheses. It would be better than to use non-parametric tests. So those have implications, outliers. Okay, so first, if they are actually a result of some errors, you want to delete them, to discard them. If they are genuine, Then there are implications. So when it comes to choice of statistical analysis, so we need to know about them. So to detect outliers, we have two main techniques that what we're going to look at. The first technique is referred to as the Z-score technique, and the second technique is the interquartile range technique, okay, as we might call it. Now the Z-score technique is very simple. We just need to take all the values and then calculate the corresponding standardized scores, and then we look at the extreme ones, and we have a threshold value which is normally used, and the threshold value which is normally used is a standardized score of 2.5. So anything which is 2.5 or greater can be considered to be outliers. Now depending on the size of a sample, the threshold value can change. If we have like relatively small samples, 80 or less, then 2.5 is good. If we have a very large sample, more than 100, sometimes 1000, we can move up to a threshold of 4. Okay, so it depends. So we have different recommendations here. Normally 2.5 to 4 will be reasonable. The second technique is referred to as the interquartile range technique. Okay, so here we explain how to do it manually, but of course we'll be using the software SPSS, and that's easily calculated. So basically what we need to do here, if we take all the values, we take all the observations, we calculate and we look at the 25th percentile, the first quarter, and the third quarter, 75th percentile, and we look at the difference between those two values. And that's the interquartile range. So once we calculate that, then we multiply this figure by a multiplier. So the multiplier that we normally use is 1.5, so times 1.5. So here we get a value, and this value, what we're going to do, for this, to know the upper end side, what are the outliers lying on the upper side, we're just going to take this value of this observation, right here, and so that's the 75th percentile, third quarter, Q3, and we just add the product of the IQR times 1.5. Then to know what are those outliers on the other side, okay, on the low side, we just take Q1, that's Q1, plus IQR times 1.5. Sorry, it's minus IQR times 1.5. Good. So then anything which is lower than that would be considered to be an outlier. Anything which is higher than that, so let's say we have a certain score here, anything which is like higher than this score here, this value, will be considered to be outliers. Anything which is lower than this here will be considered to be outliers. So basically that's how it works. Okay, now we multiply 1.5, it's not really fixed. We have different studies, different suggestions here. Some studies suggest a multiplier of 2.2, and sometimes you can even use 3. Okay, but that's the core idea behind. Okay, so two techniques, Z-score technique and interquartile range technique. Now let's see how to perform those using the software SPSS. Okay, so let's move now to the software, and let's see how to make use of those two techniques, the Z-score technique and the interquartile range technique, to detect univariate outliers. By the way, why do we call it univariate outliers? Simply because we're looking at one variable at a time. There are some advanced techniques to look at what we call multivariate outliers, bivariate or even multivariate outliers. We won't deal with this as of now. When we look at more advanced techniques like linear regression, multiple linear regression, then we're going to look at how to detect multivariate outliers. As for now, we'll limit ourselves to looking at one variable at a time, univariate outliers. Okay, so let's proceed and learn how to use the Z-score technique to detect univariate outliers and the interquartile range technique to detect univariate outliers. And you see that both techniques can be used, and normally you get the more or less the same results, as you will see. Okay, but you might cross-check using both. Okay, so let's proceed now and let's look at how to do it using SPSS. So first is that score technique. So the steps, you go and analyze descriptive statistics, descriptives, and then you click on track here, save standardized scores. Okay, so those are the steps on SPSS. To use the interquartile range technique, we're going to analyze, we click on descriptive statistics, explore, check outliers and percentiles, and check histogram. Okay, so I'm just going to do it live on SPSS and show you exactly how this works. Okay, so let's have a real data set here. So that's a data set, and we look at one particular variable here. So that's a data set which we obtained from a survey which was done among graduates. And I will take one particular variable here. So there was a question, number of interviews. So you see here we ask graduates how many interviews they took part in before securing their job where they are currently working here. So how many interviews they attended, how many interviews they took part in. And so let's see whether we have outliers in this data set. So you see here, that's the data. So here, so we see some say 10, some attended no interview, some attended one interview. So we want to see if there's any outlier in this particular for this particular variable in our data set here. So first we'll use the Z-score technique. So we're going to analyze descriptive statistics. Descriptives. Okay, so that's the first technique, Z-score technique. Good. And here we'll select our variable. So that's number of interviews attended. That's a variable we're interested in. So you do that for any variable you're interested in. So that's good. And that's the important thing here. You need to click on save standardized values as variables. Okay, we click on OK, and we get our results. So what do we see here? We see that we have a minimum score of 0 and a maximum of 200. So here's itself, when you see a maximum of 200, it seems that there is a problem. Well, how can it be that someone attended 200 interviews? And here we're speaking, we did a survey with graduates who graduated at most 5 years ago. Wow, 200 interviews seems to be super exaggerated, isn't it? Well, it might be most likely an outlier. We get a mean score of 1.6, but then, as we said, the mean might be super influenced by the outliers. So, okay. Now, using the Z-score technique, when we clicked on save standardized values, actually what happened, and that's the important thing here. So when we did that, actually in the data set, when you go to the end of your data set, so you get this variable here. Now, believe me, that was not here previously. Okay, so it was when we said analyze descriptive statistics, descriptives, and then we click on that save standardized values as variables. That's when we told SPSS that we want this new variable to be created here. So here we are. Now, what we want to do here, remember the rule? We said that any standardized score, which is like greater than 2.5, would be potentially an outlier. Okay, so if we have a relatively small sample size, if we have a very large sample size, we might increase the threshold value. In that case, it's 100 something, so it's quite relatively small. So around 80 is considered to be small. Okay, so 2.5-ish is fine. So what we want to do now, okay, so what we'll do, we are simply going to say sort descending so that we get the largest values first.